All right.
Please.
So I'll try to keep the talk more interesting by not talking about too much about the wording, and we'll try to focus more on the demo itself. But to start with, the topic which we have got in our hand today is machine learning made easy. So although I will give you more details about what is the context of being made easy, but just to break the ice, we will be talking about elastic machine learning specifically and how it is made, deploying those machine learning models really easy once we have got data within Elastic. So before we go into the depth, just a brief introduction about me. My name is Saad, and I'm an operations analyst at Skillfield. I have been working with Elastic technology for more than 2 years now. I've got all the certifications which Elastic has offered by now. So the Elastic Certified Engineer, the Kibana Data Analyst one, and lastly, the Observability Engineer one as well. So this is me when it comes to professional work. Apart from work, I'm a snooker freak, so I do love playing snooker whenever I do get a chance to play it. You'll probably find me in one of the near clubs playing snooker, but when I cannot play, I love watching it. So, and when I say I do play snooker, by no means I'm good at it, I would say, but I at least enjoy playing it and watching it. So this is just a brief introduction about me. A brief introduction about Skillfield. So Skillfield is a company based in Melbourne, Australia. We like to call ourselves as the field of skilled professionals. We have been operating in Melbourne in the business. We have been in the business since 2016, and we are a premium Elastic partner. And one of the notions we share is we transform complex problems that our customer have got to simplified IT solutions. And below you can just see the link to our website as well, so which is skillfield.com.au. So now getting to agenda of the meetup. So I'll just start with talking about what Elastic Stack in general is, what is in a brief way machine learning is. Then I will be talking about how can we use machine learning using the Elasticsearch and Elastic Stack overall. And last but not the least, it would be followed by a demo using Elastic Machine Learning, where I will be actually logging into Elastic and doing all those analysis using the sample data I've got. So to start with, what is Elastic Stack, or what is ELK? This picture really represents the Elastic Stack in a nutshell. So on the left, we have got data collection. All right. So before we get started with the analysis or running the machine learning algorithms, doing all the fun stuff, we have to get the data within Elasticsearch, right? So we have got multiple options of doing that to get the data from our systems to Elasticsearch. For example, one of the options we have got is Beats, which is offered by Elasticsearch. So Beats is something, Beats are basically light data weight shippers, which you can just install on your host, on your systems. And based on the output you configure, you can either send data directly to Elasticsearch, or you can send it to, let's say, Logstash, and from Logstash, you can send data to Elasticsearch. So based on your use case, you've got variety of beats. Okay, so for example, you're interested in network traffic data. So packet beat would be something you would be configuring on your host. Similarly, if you are more interested in knowing the system metrics or processes, metric beat will be something that you will be configuring. Similarly, let's say if you are interested in collecting Windows logs, you can configure WinLog beat to collect the data and send it through. Similarly, we have got all the different beats, and this beats family continues to grow as we talk. One of the interesting one, another I would just briefly mention, is Heartbeat, which is basically responsible for the uptime monitoring. So it sends the HTTP signal to your application and receives it back just to know whether the application is up or whether it's down, or what's the status of your application. And then we have got Logstash. So Logstash is a server-side data processing pipeline. So when you have to do kind of heavy ingestion, I would recommend using Logstash. So the good thing using Beats is you don't need to worry about the parsing bit. All right. So as soon as you install Beats, it fetches the original logs, and those original logs will be passed for you into when you pass the data through Elasticsearch. But with Logstash, if you're just using Logstash, you have to do the data parsing yourself. You have to define those parsers to break data into multiple fields and then send the data to Elasticsearch. Or you can also use a hybrid approach. What do I mean by that? So you can configure Beats to send data to Logstash. If your use case is heavy volume, high volume of data, you can send the data from Beats to Logstash, and eventually from Logstash, you can configure data to send to Elasticsearch. All right. So what is Elasticsearch? Elasticsearch is something I would say the brain of the stack. So all the heavy lifting, all the analysis, the indexing, the storage, everything is done within Elasticsearch. So Elasticsearch cluster is basically a collection of nodes. All right. So based on your requirement, you have got different kind of roles that those nodes play. All right. For example, if you need to run a machine learning job within Elasticsearch, you will configure a node with the machine learning role. All right. And if you need to store data, or if your use case is heavily focused on storage, you would add data nodes. Basically add nodes with the role data. So you would add more data nodes. So on top of Logstash, Elasticsearch, you have got Kibana, which is basically a user interface you can use to interact with Elasticsearch. So using Kibana, you can build all kind of visualizations, interactive dashboards. So yeah, so UI to Elasticsearch is Kibana. Even when we configure the machine learning jobs, we'll use the Kibana UI. And when I will show you the demo, I will actually log into the Kibana UI and configure the machine learning job as the demo. So in a nutshell, Logstash, Elasticsearch, and Kibana, these make the Elastic stack together. All right, so quite briefly, what is machine learning? So we can define machine learning as the study of algorithms that computer performs, and it automatically iterates through the experience and improves the model which machine learning builds. So it's basically, in a nutshell, computers learning from the historical data. But to run any machine learning models, to come up with those predictions, you need to have knowledge about statistics. Okay, for example, you are interested in running a machine learning model which identify anomalies. Okay, so you would need to have some knowledge of probability. All right, the concept of probability within statistics to run those models. Similarly, if it's a supervised machine learning, based on the type of machine learning, if it's a supervised machine learning, you would need to have a training data set based on which you would train the model and then run predictions on the future data set that you will receive. So statistics, then you have got training data set. Of course, you need to have basic knowledge of how to build those machine learning models based on those use cases you have got. And finally, once you have built those models, you need to fine tune them and improve the performance of those models. So how is machine learning different using Elastic? So with Elastic, machine learning is basically a UI-based configuration. So you've got all of the controls, all of the deployments, all of the choices in the UI. So you can it's just a matter of click, and you can configure those machine learning models, and all the heavy lifting will be done in the background in the Elasticsearch for you. So once you have got the data within Elasticsearch, you can basically build the machine learning models based on that data. So what is different within Elastic Machine Learning? So I briefly talked about how you can configure multiple roles within Elasticsearch, right? So you can have a data role, machine learning role. Similarly, you have got all of the other ingest roles and data roles as well. So depending on your use case, let's say if you have got more machine learning jobs to add, or your machine learning job needs more computational power, so you can add those nodes with the machine learning role within Elasticsearch. So it is easily scalable. The more nodes you add, you would be able to run more jobs, or if your particular job needs more computational power, you can add more nodes and you can utilize the computational power or other nodes. Timeliness, for example, if you are a security, if your use case is around security, the moment you ingest data, you don't want to wait for another 24 hours to get the alert on it, right? So if case you can actually send the adopts itself. So you can do it in a very timely manner rather than waiting for a day to generate the alert and get alerted on it. Adoptable. So for example, if you have got data, which is, let's say over the weekend, the ingestion rate has all of a sudden increased and it continues to be the trend over each weekend. So Elastic Machine Learning is intelligent enough to learn that trend, and it won't actually raise an alert or show you an anomaly based on that trend. So it's intelligent enough. And for the usability, as you can configure these machine learning jobs through the UI, so you don't necessarily need to have all that background knowledge, or you don't need to be a data scientist to or a data engineer to even configure these machine learning jobs in Elastic. So what are the types of machine learning job that Elastic supports? Broadly speaking, these are unsupervised machine learning jobs and the supervised machine learning jobs. With unsupervised machine learning job, you don't need the training data set, of course. So it's more of a learn by doing approach. As soon as you feed the data to Elasticsearch, it learns on its own and it identifies the future trends or the analysis you want to do on it. So within unsupervised machine learning, we have got anomaly detection. So for the anomaly detection, it's really important that the data you've got is a time series data. So there is a timestamp field within it, which can help you toggle through the time. So you need to have the time series data. And another thing is, with machine learning, you can also run the forecast based on that time series data. All right. So how the data will appear in, let's say, in 1 day or in 2 days further from when the model has been built. And the second one is the outlier detection. So it does not need to run continuously, unlike the anomaly detection, where you are continuously detecting anomalies within data. So outlier detection does not need to run continuously. You can basically, so in the background, what happens is between the data points within the cluster, it calculates the distance. And based on that distance calculation, it calculates, okay, if this data point is outside this limit, it will basically identify it as an outlier. So this is for unsupervised machine learning. For supervised machine learning, you would need the training data set to train your model and then run those predictions on the data. Firstly, we have got classification, which basically predicts the categorical values for you. For example, you've got an email server data and you want to identify whether the email you are getting is a spam or not. And there is a categorical field which identifies it. All right. So using the classification model, you can actually run the predictions on that field, and it will predict whether the email is a spam or not. Similarly, for regression, it will predict the numerical values. For example, you have got web log data, all right, and you want to know how much time does it take for a request to reach to the server. So this is something which you will call a continuous numerical value. So you can calculate that value using the regression model. So these are the two broad types of machine learning you can run within Elasticsearch. But before you opt for the machine learning algorithm to run in Elasticsearch, you need to consider a few things. All right. Firstly, although Elastic itself is open source, but the machine learning feature itself that comes with Platinum license. So that is, and there is a cost associated with it. Depending on the configuration you have got or the deployment you have got, the cost would vary, right? And before building any machine learning model within Elasticsearch, it's a really good practice to firstly read the data, what your data represents, all right, and then identify the purpose. What do you want to achieve with this machine learning job, right? And lastly, the usual perception is if it's an anomaly, it's bad, right? But it's not always the case. So anomaly can be good or bad, depending on your use case. For example, if you are running an e-commerce business, all right, if you've got an e-commerce website and all of a sudden you have got high count of events coming in, right? It means your business is basically doing good. So it's a good thing. Whereas if you have got a lot of failed logins coming from a particular server and you as a security-based company, it means bad. So the context is really important when we talk about the anomalies here. So these are just a few things to consider before we actually jump on to configuring the machine learning jobs within Elastic. So before we go to the demo, I will just identify or talk a bit about the sample data which we have got in hand. So the sample data which we will be using is actually provided by Elastic. So it's a mock web traffic for the Elastic website, and it basically has these key fields listed down here. So the response code basically shows whether the request has been successful or not based on the response code. We can see that. Then we have got the client IP, which shows from where has the request originated. Similarly, we have got other fields like who has referred the request, whether it's coming from Twitter or another source, the request itself, the URL used in the request, and finally, the agent. So that's about the sample data set. Now I will just straight away jump to the demo to start the action. All right. So as soon as I have got to the demo, so this is the Elastic homepage I see. So you can deploy Elastic in a variety of ways. So one of the way would be to deploy it on your own environment. So and it can be an on-premise deployment, all right? And then you have got an Elastic Cloud deployment. So with on-premise deployment, it does take, you need to install Elasticsearch, you need to worry about the security, you need to configure it. Then you've got different Kibana installation and configuring security for Kibana. Similarly, if you're using Logstash, you have to configure that as well. You need to worry about the certificates and all. Well, Logstash would anyways be a local installation, but when it comes to Elastic and Kibana, another feasible option for us would be to use the Elastic Cloud. All right. So it's just a matter of couple of minutes and you can have your deployment running if you want using Elastic Cloud. And Elastic Cloud does offer you a 14-day free trial. So you don't have to enter your payment details and you can get started with the trial right away. All it needs is just your email address. Right, so this is the home page of Kibana showing the Elasticsearch window, and I can see some use cases here. So these are some of the use cases which Elastic covers. It is quite heavily focused on security, observability, and then enterprise search. We won't go into analytics, of course, as well. We won't go into these details, but what I want to show you is if you haven't got any integration, if you haven't got any beats installed on your system, or your beats is not sending data to Elasticsearch, and you just want to play around, you can either upload a file. It could be a CSV file or in any other format, or you can even try the sample data which Elastic has already got, right? So if I click on the sample data, I've got three options here. So this is an e-commerce data that I can use, flight data, and this is the data which we will be using to develop those machine learning jobs, right? Sample web logs, which is the mock data we are using. So if I go here again, I can see the machine learning tab here. All right. And as soon as I add this data, what it does is in the background, it adds a few more bits for me, right? So it will add by default some dashboards, all right, which I can see and find some details, all right, what the data is about. If not, I can go to machine learning and I can actually visualize the data there as well, right? So let's say I'm into the machine learning tab. This is an overview window for machine learning. And I can see, we can see we have got one machine learning node which is active, and it has got 1 GB memory, which is, yeah, not too heavy. And then we have got these machine learning jobs, anomaly detection machine learning jobs in this window as well. So before I configure any job, a good practice would be to actually see what I have got in data, right? So I can go to this data visualizer, data view, all right. And here I've got all the data views, all the data which I've got in Elasticsearch. So as I am using right now, the sample data set, which carries the web logs. So I can click Kibana sample data logs, and this will show me the data view of these data logs. So by default, the time picker says 15 minutes. You can adjust the time here, but it's better to have more data to run the machine learning models, right? So the more data you have, the more accurate that machine learning models would be. So, and to have a better picture of the data, I'll just click use full data. All right. So the number of documents or the number of rows for the data are this much, 14,074. And these are all the fields within the data. All right. So I can see I've got agent, client IP, event.data set. So how many of them are actually the metric fields? I can see that number here. So 5 of these fields are metric fields. So these are denoted by this hash. So bytes, similarly R of day, machine RAM memory, and PHP memory. I've got the second page as well, but these are all the 5 number fields I've got, or the metric fields I've got. And I've got a few fields which are the IP type as well, like client IP or just the IP. All right. So this is just the overall view of what data looks like. Now, once we have seen the data, let's go back to the machine learning tab and actually start creating a job. So although in Elasticsearch, we have got 4 types of different machine learning jobs which we can create, as we have seen in the slides. I will be creating an anomaly detection job. And let's go to manage jobs and manage jobs. These are the existing jobs I've got. And to create a new job, I'll just click create job. And I will pick up the same data set that I used previously, Kibana sample data logs. All right, so as soon as I click it, it is showing me some of the pre-configured job as well. So this particular job is already configured for me. So if I click it, I would be able to see these details about the pre-configured jobs. Similarly, when you ingest data using beats, you will have some pre-configured jobs already there for you. So you can just use them straight away. But in this case, we will be actually creating a new job for us. So in this wizard, I can see I've got a few options: a single metric option, a multi-metric, a population, and even advanced categorization, and so on. So a single metric job basically relies on one number field or one metric field, and it detects anomalies based on only that field, right? But when we talk about multi-metric, it depends on multiple metrics or multiple number fields based on which it will create or detect the anomalies for you. So you would be getting a total anomaly score, and you would also be getting an anomaly score for each field. So for the purpose of the demo, we'll start or we'll do the single metric job, single metric. And as soon as I click it, I can see the time range. So it is asking me about how much data you want to use to create this machine learning job. So the more the data, the better it is. So I'll just say useful data. And this is just the time series distribution showing data. And I will just click next. And as soon as I click next, I can see I am able to pick up the fields which exist within data. All right. So machine learning here is intelligent enough to see based on whether the field is a metric field or a categorical field. It can, or a text field, it can actually show those metrics for you. All right. So for example, this event rate is not the field itself. It's basically the number of events or the number of documents that are coming in within this particular index, the Kibana sample data logs. Or if I go down, bytes was metric field. So for bytes, I can calculate mean, high, mean, and similarly all the different min, max, and statistics I can do on it. For example, client IP was a text data field, so all I've got is the distinct count of it. So I've got options of making this machine learning model or deploying this machine learning job on the field of my choice. For purpose of this demo, I will pick the count of event rate. So it will create an anomaly whether the count of event is high or low. All right. So if I'm just interested in the high count, I can pick this or low, but this will create anomaly in both the cases. So I will click count of event rate, and as soon as I click the count of event rate, it shows me a couple of more options. One of them is bucket span. So how I want to basically divide the data within this time interval. So by default, it says 15 minutes. Now this bucket span should not be too big or should not be too small. So an ideal scenario would be, or ideal value would be somewhat between 15 minutes to 1 hour. All right. So for example, if I've got 15-minute buckets, and for the first two buckets, all right, which comprise a total of, which make a total of 30 minutes. So the moment the machine learning model analyzes the third bucket, it will use data or data from the previous two buckets, right? So on the basis of analysis done on the previous two buckets, it will predict the pattern for the third bucket. All right, so that's why it's important to not have this value too big, or similarly not to have this as too small as well. We don't want to have a multi-metric job right now, but if we want to play around with it, a good use case can be, apart from the event rate, we might be interested in where are these events coming from. So in that case, we can also use another metric, maybe like a client IP or some other metric field, excuse me, we can use. So right now it will be a single metric job. I'll just click next. Here we have to specify the unique ID for the job. All right, so I will just name it Queensland Advanced Analytics Meetup Demo. All right, so this is the job ID. Group is something which is more like a labels, and you can assign or have multiple jobs in the same group. So you can either select the already created group, or you can create a new group of your own. So I'll just assign Kibana sample data for it, and I can write the description, although it is optional. So this ML job identifies high or low count of documents. All right. And if I go to additional settings, I can have custom URLs assigned here. So For example, if the model identifies an anomaly, I can configure a custom URL to go to further analysis. And similarly, let's say if you have got scheduled maintenance, you know, okay, during this time period, probably the number of anomalies will increase, but I don't want to be alerted on them, or I don't want the model to treat those values as anomalies. So you can import the calendar, and you can actually have the machine learning model ignore those events during that time. So this is for the additional settings. Within advanced, similarly, we have got the model plot, which will store the model information, model annotations as well. You can store the memory limit is something really important. So based on the data feed you, or the amount of data, or the processing that your classification model, or sorry, the machine learning model uses, you basically assign this memory limit for the model. And once you have assigned this memory limit, you cannot change it after creation of the machine learning job. All right, so this is something you need to specify when you're creating the job. We would be able to see whether this memory is enough for the job or not in the next step, but you cannot change it once you have created the job. And the last thing is a dedicated index. So by default, all of the results will go to a particular index, which is .ml anomalies. But if you want to have another index defined for it, you can select another dedicated index, and the results will actually, the anomaly results will actually go to that index. So this is the validation steps. It tells me, all right, the time range is enough, valid and long enough to model patterns, and the model memory limit is also valid. So the validation looks okay. I'll just go next, and here I can just see the summary view. So as soon as I will create the job, it will start immediately. So I will just click create job. And as soon as I click create job, we can see machine learning doing the magic for us. So if we see to our extreme left, the machine learning model, the anomaly detection model, did not have enough data points, right, to identify this trend, the higher and the lower bounds of the time series data, right? But as soon as it has got more points, it can configure or figure out the pattern of the number of events coming in. So the job has been created for us. We can go to view results to view the results. All right, so this is a single metric viewer. So we have got two different views we can use within anomaly detection, a single metric viewer and the anomaly explorer. We will start with the single metric viewer. So this is the total timeline of data. We have got the time picker here. We can expand this time picker, and it will start to show from the very beginning of time when we've actually got the data. So I can see some light color circles here, which are showing me the anomaly. All right, as soon as I hover up onto one of them, it is telling me, all right, the actual value which you have got at this time interval is 13, whereas the upper bound is 10.6, which is still close. So that's why the anomaly score is not that high. Similarly, I've got all these other points, all right, 17 and 11.8, not too far. But when I go to this anomaly, I can see the actual score that was seen here was 63, whereas the upper bound is 11.6. Now, that's a huge difference, right? So what the anomaly score means is that the probability of having 63 as the value was really low. That is why we have got a really high anomaly score of 98. Okay, so this is what the anomaly score basically here means. Now, if I scroll to the bottom, I've got the individual anomalies at the bottom. I can just open one of these anomalies. For example,
I'm sorry, Saad.
Yeah.
May I know what data are we talking about here? You're talking about anomaly of what kind of data?
So
You choose one feature, right? Only one
yes.
feature, one column. What feature was that?
So that feature is actually count of the documents with respect to the time. All right.
Okay.
So for example, if you have got a high count of events coming in, it would be treated as anomaly, or if you have got low count of events, that would also be treated as the anomaly.
Okay, so the count of, so what data are we talking about? The sample data is about what again? I'm a little bit lost
So
there.
it is about the web logs.
Okay, so the
Yeah.
document that was accessed on the web server.
Yes. So the number of
Okay.
requests actually.
Okay, the number of
Yeah.
requests.
Yeah. So
We're
the
looking
request
at
that
the
has
count.
been made
Okay.
to the web server.
Okay. So
Yeah.
we're tracking down the count of the request, and we're tracking down.
Yes.
Okay. Thanks.
Yes. Yes. That's correct. So, all right. And when I go to the Discover tab, I will actually show you the different fields within the data. So that should be self-explanatory as well. So if I see these anomalies, very high severity anomaly, I can see, all right, these details about 63 is the value, typical value is this, which is actually 10 times higher. That's why it has got a high severity, and this is the probability value. All right. Now, for each anomaly, I've got an option to actually go to the actual event, all right, or the actual time window during which this anomalous behavior was observed. And I can see for myself what is actually happening there. All right. So if I just view this in Discover tab, I can see, all right, we have got 332 hits during this time interval, which was an anomaly, which is probably, yeah, we have got a high count here. Now, to get more details about this anomaly, I've got all of the fields available here, right? So one of the field which I might pick is, or which might be of interest to me is where are all these requests coming from? Okay, for example, it is the client IP. All right, so client IP will show me, okay, these are the different client IPs which are actually sending us the request, and I can easily spot a client IP which makes 30% of these requests, right? So it is this particular IP. So what I will do is, for the sake of just representing it in the model, I'll just copy it. And if I go back to the model, this was the actual anomaly. So another thing I can do here is I can annotate this anomaly, and I can include some information here. For example, I'll just say high count of events is seen for client IP, and I'll just paste the client IP here. All right. So as soon as I click create, I am seeing the annotation appearing here. So next time, whether it is me, whether it is anyone else, as they go to the single metric viewer, they would be able to find some information about this anomaly. Another thing we can do in the single metric viewer is forecast. But before doing that, let me show you the other view of anomaly detection, which is the anomaly explorer. So this basically shows you a timeline with respect to the anomaly. The highest anomaly was around this time, and yeah, it's basically the same anomaly in a different view. If we had a multi-metric job, we would have anomaly score with respect to, let's say if we are having a job with respect to two different metrics, we'll have anomaly score with respect to two different metrics, and then we will have an overall anomaly score. So right now it's a single metric job. That's why both of these timelines look the same. At the bottom, we have again got the same options. And now if we want to forecast this data about, if you want to find out how will the data look in the future, so I can just click forecast, and it can forecast up to a maximum of these many days. And if I want to forecast it for 1 day, I'll just select 1D and run. All right, so I can see it has run the forecast for me. So in the future, this is the prediction of the model, how it will look like. All right. So right now we have configured the anomaly detection job, but it is not something which is running in real time. Okay. So if we want to keep this job running for the future events, which will continue to pop up, we need to go to this window, or we can even start the job in real time when we configure it. But let's say if we haven't configured it back then, I will need to start the real-time data feed. So I'll click Start Data Feed, and it's asking me to specify the start and end time. Start time would be the same, but if I don't specify any end time, this will be a real-time search. All right, so I don't specify any end time, and I've just started the model. So as soon as I started, I can see the data feed status here changes to started. And I can see the active data feeds increase to 1 from 0. Another thing we can do with anomaly detection is actually create an alert rule based on it. I can, for example, every time it throws an anomaly based on the condition defined in the alert rule, if it sees an anomaly, maybe send a message on the Slack channel, or we have got other integrations as well. So for example, I've just named it to write to Slack, and it will notify whenever the status of the job changes, checks every minute. I won't change any of this. And if the severity of the severity score is equals to or higher than 75, take an action. And what will be the action? Now, based on the connector type defined, you can configure these actions. For example, if you want to have this data saved, have this alert data saved in a separate index, you can define that index here. Or if you want to send this message to any other service, for example, Slack, you can select Slack, and I've configured this connector for the Slack. And whenever the anomaly score matches the condition in real time, it will actually send me the alert. And you can basically attach multiple action items to the same rule. So you can send the message to Slack, and similarly, you can have another action where you can save the same data to a separate index within the same Elasticsearch cluster you've got. So I'll just save this. And yeah, so we have got the machine learning job for us. And if it throws anything, we should be able to see something in Slack, but I'm not expecting anything to pop up at the moment, which will be highly anomalous. So yeah, that's for the anomaly detection using the machine learning job. And I'm happy to take any questions with regards to this demo. If you've got any.
I didn't see any discussion of what are the models you're using here. It's just point and click, and everything is automated in the background. So what are the details of the model and your forecasting algorithm, for example? What are those?
Yeah. So for these anomaly detection jobs, in the background, how we are calculating, what do you say? How you're calculating the probability, or how you're calculating that anomaly score.
Yeah.
So in the background, it's running a probability model. All right. And based on that probability model, lower the probability, higher will be the anomaly score. So for anomaly detection jobs, we are running probability model in the background.
Okay. Probability model.
Yeah.
And you cannot tweak the parameters of that.
So for tweaking the parameters, you have got other options. Like this is something really simple as a single metric job, right? If you want to have the full range of the options, you can use the advanced use cases. All right. And you can tweak those parameters defining there. But even for, let's say, the data feed you are ingesting, and you can define those conditions. So
now
all
let's go
of
back to
these things.
let's go back to the single metric, so it's easier. So how
Mhm.
can you change the parameters there? Do you have any parameters that you can change?
So the only parameters within the single metric job you have got is, let's say, this bucket span. All right.
Okay.
So the number of buckets or the interval of buckets you can define. And if you want to ignore the empty buckets, all right, you can select this. And then you have got these additional settings you can define. And within the advanced, this is all what you have for the single metric jobs.
Okay.
All right. But if you want to tweak further parameters, you would need to switch to an advanced level of job, not the single metric job.
Oh, okay.
Yeah.
Okay. All right. Thanks. And the other one is you're forecasting what algorithm are you using and how good is that algorithm? Then how can you test the how do you know that it's like performing well?
So to be honest, with these number of documents being ingested, these are what, like just 14,000 documents. I don't expect this forecasting to be accurate. All right. The more the data, the better it would be. So for example, over the time, it ingests, let's say, 1 million records or something over a week, and if I'm running algorithm or the machine learning model based on that data, then I expect my forecasting behavior to be more accurate.
Yeah. That's all right. But what algorithm are we using here?
So it's the same algorithm. So
it's probabilistic algorithm? Or?
Yeah. So this anomaly detection. So in the background, it uses the probability modeling for you. So as you see at the very start,
what are we predicting, by the way? In the prediction part, in the forecasting part, what are we predicting? Is it the number of counts?
Yes, the number of documents.
The number of documents.
Yes.
Is what we're forecasting.
Yeah.
I'm a little bit confused there because you're forecasting the number of documents, the counts, but then on the other end, you are actually running a machine learning to detect the sort of the outlier there, right?
So again, this outlier is with respect to the count of documents, right?
Yeah, but then your forecasting is the count of document, right?
Yeah. So based on what machine learning model has learned here, it is doing the forecasting, right? So if it experiences something which is outside of the upper and lower bounds,
yeah,
all right, it will treat it as an anomaly, right?
Okay. It's so much abstraction here. I cannot see the connection between the graphics that you're showing to us and the actual algorithm. That's a problem, and that would be a big problem for me because how can I explain this to my users if they ask like how do you know that this is correct? I don't have any description of the algorithm. Yeah. It's like you need to trust us, and unfortunately, it doesn't happen in the real world. Some people really need to understand, what's going on under the hood.
Yeah. So
yeah.
So that's kind of the trade-off, I would say. Like if it's someone who does not know that much details about how to improve the accuracy of the model or how to tune them and stuff, so this is something they can use. They don't need to be a data scientist or someone.
So we don't even know what library is being used here. Is it from Google? Is it from Facebook? We don't know the libraries being used in the background, or do you have your own libraries in the back end?
So there is another option of, so this is something which you can configure using the UI. All right. So there is another API based approach as well, where you have more control over the parameters. Okay. Gotcha. So yeah, but that is something for the advanced users, right?
Okay.
So you can easily use that API documentation and tweak those parameters around.
Okay. And lastly, this can run as you mentioned. I think you can run this on-prem or on the cloud.
Yes. So Elasticsearch is something which you can run on-prem, or on cloud. Having said that, machine learning feature itself is not free for Elastic. You need to have a platinum license or an enterprise license to run it.
And you can run it in AWS, Azure, or whatever cloud.
Yes, whatever cloud provider you want to.
Okay, thanks.
problem. Any other questions?
Last call, any question for Saad? I think that was a really good
Quick one,
presentation.
sorry, it's me again. Do you provide a like trial access or something like that? Like
Yes, so
Databricks? Okay.
so you should be able to get a trial access. I'll just shoot the link for you.
Yeah, that would be good in the chat window, right?
Yeah, I'll just.
Because I believe Snowflakes provides some Databricks. I'm not sure.
Yeah, so it comes with a 14-day free trial.
Mhm.
So I'll just shoot that link through in the chat.
Okay. All right. Thank you very much.
Not a problem.